So what we're gonna do, we're gonna just erase these values and give it a name, give the accurate value. So in ky, because it's braced in that direction, we're gonna give equal to 1, and in kzz that is 1.7. This is calculated based on GA and GB for the column, all right? So we're gonna give these 1.7. Not to ask Risa to calculate, and these two other members are not columns, so it doesn't matter whatever you give. So the function rule doesn't matter if it's lateral or gravity. Make sure that you choose the right ky and kz and then apply our loads. So loads are joint load here. I'm going to apply point joint load, but I have to say what load case is that before that. So we're going to go to the basic load cases. I'm going to just label it as dead load, and the category is of course dead load. It's in y direction, -1, and the same thing for the live load, LL. The category is live, and that's -1 for the direction. Okay, and then we're going to apply that. This is a load in direction -500, and that's live load, or dead load is -250, and then I'm going to apply it here, plus the live 500 live load, apply here. Now I can see from the load combinations, I don't have the load combinations, but I can see both cases here. Okay, the dead load if I was applied, and then the live load. So now we need to create the load combinations. Create one, and that's 1.2D plus 1.6 LL, or just L. So direct the solve for the P delta, yes. Our first BLC is the dead load, yes, basic load case 1, the factor is 1.2. Then we have load case 2, and the factor is 1.6. So create that. Now if I click on the load combinations, it should show up here, right? This is unselected, so I'm gonna see in my spreadsheets and then loads if it's correct on a point load. Yes, BLC, it's live. Then I have the dead load 250 at node 2. So that's applied. These are the basic load cases, and these are the combined. So P sub U is going to be -1100 kips here applied. So we introduce also loads. Now we can run the analysis and see if it's adequate enough or not. Single load combination, run for that. Okay, solve, and go to the design results. See if this beam, this column is adequate enough. So the materials is A992. Its LB is 15 feet. We see maximum bending check is 0.934. This is not just for the bending in AIC, in RISA 3D. This is unity check, and when we go to this chapter of beam columns, we're going to talk about this equation H11. So this value is general, doesn't mean it's if it's beam or it's column or it's just compression member, tension member. This means the ratio of your applied loads to your strength is 0.93, and as long as it's less than 1, it's adequate enough. And then we have KL over R in x-axis and y-axis. You see that in z-axis, which is our strong enough axis, it controls. And based on that, our phi times P of n is 1206. This given answer from the solution in the textbook is 1205 kips, which is about the same for us. And then that applied compression force is 1110 kips, all right, at 15 feet. So this member is adequate enough. We check that. Our problem part 1 is done. Now we can go to the part 2, which means that we're gonna now create a new load case, and that's our lateral load. See if it's gonna be strong enough or not. I'm gonna create wind and